Hello everyone and welcome back to my channel. In the previous video, we studied about modules in Python. We have seen the standard module, the user-defined modules, and even the third-party modules. And here, this is a video where we are going to visualize some of our inbuilt or the standard modules that are available in Python. So we are starting with the math module. Now, this module provides access to all the mathematical functions that are defined by the C standard. Now, it includes functions which can work on iterables, integer and float values, and it reduces down the probability of performing the mathematical steps logically into the program. So this is going to drastically reduce the number of lines of codes if you actually import math module to solve the mathematical functions. Now, one thing to be noted is that these functions cannot be used with complex numbers, right? So for that, we have a separate module which is known as CMath, and here C stands for the complex number. So if you want to work on the complex number, what you have to do is to import CMath module in place of math module. But here in this video, we are going to concentrate on the math module. So let us go to our Visual Studio Code and start seeing the functions that are available in math module. Now, the first step in order to use this standard math module is to import it into our code. By this import keyword, what you are doing is you are importing each and every function that are available in math to this current session of your Python program. So, the first function that we are going to see today is the ceil function, right? What it does, it takes an integer as an argument and it prints the greater than value or equal to the greater than or equal to value of x. So let us see how this works. Now let me just initialize a number, let's say num, and let the value of num be 25 point something, right? A big number, floating point number. What I'm going to do is I am going to call math dot ceil function on this number, right? And what I'm going to do is to actually pass the spelling is wrong, so s the ceil function in it, right? And the next thing is to print the value of num, right? So like this. So here we have taken a floating point value, right? And we have passed it inside the ceil function, and we, in order to call it, because this function is inside the math module, so this is the syntax of calling this function as math.ceil. Now if I run the code, then you can see that here the value is round up, right? So we got 26 as an output. Similarly, we have an exact opposite function of ceil, which is known as the floor function, that also takes a value as an integer, right? So if I just copy and paste the same code over here, and in place of ceil, if I write the value or the name as floor, and if I now run the code, what I got as my answer is nothing but 25, right? So this is the floor value and this is the ceil value. Now, coming back to the next function, which is number 3, and that is the power function, and it going to take two argument, let's say x and y. Suppose we want to calculate the power, so in order to call it math dot power, POW, and I want to calculate, let's say 10 raised to the power 2. So let us see what we are going to get as an output. So the answer should be 100.0, right? So, all right, I haven't printed yet. So it should be print P. So if I run this code, the answer is 100.0. Now, if I change it, let's say I want to calculate 5 raised to the power 2, the answer should be 25.0, and so on. So this is working as the exponent, and which is the name of the function is as power. Now talking about the fourth method or the fourth function that we are going to see today is, let us say it is square root, SQRT. As the name suggests, it is going to give the square root of a number. So if I take num is equal to math dot sqrt, and inside it let me take a number, let's say 25, and if I print the value of num, the answer should be 5 this time. So this is going to calculate the square root of any number. So if I run the code, the answer is 5. If I take it as 36, the answer should be 6, and if I take it as let's say 100, then the value should be 10, right? So this is the square root function. Very simple and most used function it is. Now coming to the fifth function, which is f_abs, that is the absolute value, right? So if I run the same code over here, just copy it and paste it over here in place of sqrt, let me write this function, right? And if I give the value as, let's say, minus 68, let us see what we are going to get as the output. So if I run the code, and you can see that what I got is the absolute value, right? The sign is not been considered over here. It is going to return the absolute value, that is the magnitude of the number we have passed over here. So that is also a very simple function, right? But it is required many times to actually get the magnitude of the value. Now the next function is the factorial function. Yes, we can calculate the factorial of any number just by using this particular method or function, which is factorial, available in math module. And here in our Python series, we have seen the complete code of calculating factorial. So let me just make a name as fact, and math dot factorial I'm going to call, let's say, for 120. And if I print the value of factorial of 5 is 120, so I need to pass 5 over here. And if I print the value of fact and run the code, you can see that yes, 120 is now been printed on the screens. Let's say the factorial of 8. Now factorial of 8 is now printed on your screens. So see how this particular math module is reducing down the lines of code. You have calculated the factorial of a number in just a single line. So that is the essence of actually working with modules. So you can make your own modules if you find that any algorithm that you have implemented has actually have a significance in programming. So you can make it as a module, and you can add it to the community of Python, and everybody can work upon it. Now the next example that we are going to take is our seventh function, which is available in the math module, and which is very interesting one, that is fsum. Now this is going to take an iterable as a argument, and let us see s is equal to f math dot f sum, right? And inside it, it is going to take an iterable, and we know that list is an iterable. So let me pass a list. Now what this f sum is going to do is, as the name suggests, it is going to calculate the sum of each and every element that is present inside this list. Yes, so this is going to calculate the sum of the numbers. And if I print the value of s, you can see that the sum is 15, which is printed on your screen. Now, similar to fsum, we have another method which is nothing but calculating the product of the iterable that you pass in it, right? So this is the eighth function, which is nothing but prod, short form of product. And if I call it as, let's say, math dot product, and if I pass an iterable, let's say I want to calculate only two terms, I'm taking 5 and 4, and the product is 20. So if I print the value of num, it should print 20. So here I got the product of the iterable that I passed inside it, right? So these are the functions which are very handy, and which is going to reduce down each and a lot of code from your programming, right? So the next example that we are going to see is, let's say, your ninth function, which is calculating the GCD of some numbers, right? So if I call it as GCD is equal to math dot GCD, and inside it I'm going to take some integers. Let's say these are my integers, and if I'm going to print the value of G, now this G should be the greatest common divisor, which is 1 this time. Let me just take some other values here. I think the answer should be here, which is 2. Now this is the greatest common divisor which is available. Similarly, we have another method which is calculating the LCM. Now here you can see that each and everything that we have studied in our mathematics are now converted into a function, right? So we can also calculate the LCM of certain integers. So if I call it L and math.LCM, and inside it I'm going to take certain integers, and if I print the code as L, so this is going to print the LCM of my integers that I have passed over here. So you can see 360 is the LCM, and that is now printed on your screen, right? Another function that we have with us is calculating the permutation and the combinations, right? So that is also available in the math. Each and everything which we have actually studied in our mathematics is available with the math module. So the first thing is permutation, and the second one is combination. Each and everything you can see. So if I call the permutation as P, and if I call math dot perm, in the brackets you can have values as, let's say, 2 and 4, and let's say I call it as the combination, so I will be calling comb, and let's say this be 2 by 7, and if I print the value of P, and in the next line I'm going to print the value of C, and you can cross verify the answers. All right, so it should be 4 and it should be 2, because I readily do not remember the formula of permutation and combination, so I have to take the values wisely. So I have just reversed the values, and yes, you can see that the permutation and the combination answer is now been printed, and you can actually check it that whether the answers are correct, and definitely the answers are going to be correct. Now we can also have trigonometric functions, logarithmic functions available in the math module. So here we are going to see the trigonometric values that are available, that is the sine, cos, and tan values. So if I call S is equals to math dot sine, and what I want to get is sine 90. So let us see what is the value of it. If I clear the screen and run it, you can see, okay, I haven't printed the value. So if I print the value of S like this, you can see that this value of sine 90 is now been printed on the screens. Similarly, we have the cosine value, the tan values, and so on, right? So this was something about the trigonometric functions that are available. We have similarly the cos and the sine values. Then we have logarithmic values also, right? So we can also calculate the log of any numbers. Let me call it as L dot log. If I am going to take only log and pass any value, this is going to take the natural log, which is the base E, and if I print it, you can see that the value of log E base E 4 is now been printed, and if I make it as 10, then the log base 10 value is been printed, right? So both the values are different, and here we can also make use of log methods inside the math module. So you can see that a lot of things has been actually covered in the math module which we have studied in our mathematics, and also it has certain constants also defined inside it. We know that modules is a collection of functions, classes, methods, and variables, right? So math module also have certain constant value. If I print the value of pi, if I print the value of, let's say, math dot e, if I print the value of, these are the actually terms that we have used in our mathematics, tau, right? So a lot of things are available in the math module. If I print the value of, let's say, math dot infinity, right? And if I run the code now, and you can see what is going to get print on your screen. So this is the value of pi, 3.1415 and so on. This is the value of E. This is the value of tau, and this is represented, INF is represented by infinity. One more thing which is available in the math module is not a number, right? So that is, let's say, any n, not a number. So if you print it, so it is printed nan, that is not a number on the screens, right? So that was a little introduction of what all things are actually available in the math module, and I hope that you understood that by using and importing modules, we can use the inbuilt functions that are available in it, right? And we can actually make a, sophisticated code, and reducing down certain, the logics that are involved in calculating these values. So I hope you enjoyed the lecture. Thanks for watching.